Hey you guys, now that we have created our rectangle class, we are now going to move on to our cube class. So what I did right before this video started is that I copied the rectangle header as now the cube header to highlight how similar cube is going to be to rectangle and kind of show the need that it'd be pretty advantageous if cube can inherit from rectangle. So why don't I take a look at cube.hpp. Here it looks a lot like rectangle because it's exactly rectangle. So what I'm going to do is that I'm going to first rename rectangle to cube. I'm going to add an additional attribute called depth because now we're going to be in the third dimension. I'm going to change protected to private, and rather than area we're going to have surface area. Rather than perimeter, well, we're going to have volume. Now with the constructors, of course, it needs to be the same name as the class, so I'll need to update that. And for the parameterized constructor, I'll need to add a depth argument so that way the third attribute can have a value. So then here I'll have cube, I'll replace this with C, and then here this should also be cube. The destructor will also be named cube. So we're going to have our length and width getters, and now we're going to add a depth getter. We're going to change the area to to surface area now, surface area, and now perimeter will be changed to volume. We'll have our set length and set width, so I'm going to have to copy set width so that way we can add our set depth, change the input to depth so that way it kind of makes sense of my intentions. Calculate surface area and then calculate volume. With these methods out of the way, and oh man, I made an oopsie here. Let's do that. Const cube, and it doesn't have to have a space, so const cube C. Okay, this all looks good. We're going to have the exact same print method, but the difference between the print method in cube and the print method in rectangle are going to be similar but different. Continuing, I want to overload the plus operator, but rather than return a rectangle class, I want to return a cube class. Same thing here, the inputs should be cube, and we'll replace this with a C, and then here we have cube instead of rectangle, replacing the argument with C. Finally, we're going to be overloading the double angle brackets operator, but now instead of using rectangle, we're going to be using cube. And actually, just to spice things up a little bit, I'm going to add a multiplication operator with multiplying an integer, similar to how we did it with the point3D class. So with this, I have my header file, I have the declaration of the class cube, and already I mostly just added a few methods. I changed a few methods and I added a few methods. And when we go to the implementation of cube, we're going to see that a lot of it's going to be copying the stuff from rectangle. And actually what I will do is that I will copy rectangle into the implementation of cube and we'll transform it into cube. Here I am. So what I'll do is that I'll copy the implementation of rectangle as cube.cpp. Got to make sure that it's a capital C, not a lowercase c, to avoid some confusion. And here we are. So instead of including rectangle.cpp, we're going to be including cube. So now, because these are going to be part of the cube class, we need to show that each one of these methods are going to be, well, part of the cube class. So then I need to do an additional initialization for depth, and then rather than have perimeter, I'm going to have volume, which is this is the multiplication of the three, so this will be 1, and then I'm going to have surface area, and this is going to be 6 times each one of the surface, each one of the area. So this is going to be this is going to be 6, because this is going to be the length times the width times 2 plus the length times the depth times 2 plus the width times the depth times 2 to represent the multiplication of each dimension. So then we continue on to the parameterized constructor. I gotta change stuff to cube here. So cube, this is going to be cube. We're going to be adding our third input parameter, which is going to be depth. And then here we initialize depth, and this is getting a little big. So I'm gonna put this on a new line. And let's do that. And then we'll have our set depth with the input of depth. And then instead of calculate area, we'll have surface area. And instead of perimeter, we're going to have volume. We continue the same thing of converting rectangle to cube. It's a little bit of a painful process, but in my opinion, it's better than rewriting the whole entire thing from scratch. So then here I'm going to have the depth of tribute be copied. So C depth. And then we'll have, rather than area, we're going to have the surface area. That should be an underscore. Surface. Oh, there. Surface area. And then here, rather than perimeter, we're going to have volume. I gotta replace this with the C, and then here we'll have volume. Right, so here I'm making sure that C is copying all of its attributes to the current cube class, and yeah, this all works. I'm going to have an empty cube destructor similar to the rectangle class's destructor. And now we're going to need to put cube for the length attribute, cube for the width. I'm going to copy this, and instead of the width getter, we're going to have depth, and then instead of returning underscore width, we're going to return underscore depth. Right, but these three getters are very similar. So instead of area, we're going to have surface area. Kind of just, again, we're kind of molding this to serve the needs of cube, right? With each one of these getters, I just want to return just the attributes that are there. Right, since I changed my area attribute to surface area and my perimeter to volume, I need to reflect that with my getters. And I do so here. Finally, we get to our setters. Our set length and our set width don't really change too much. The only thing that changes is that we need to make sure that it is part of the cube class and that our surface area and volume setters are being called. And then I also need to make one for well, whatever, that's fine. I also need to make a setter for the depth. Oops, there we go. The setter for the depth, and well, let's write that out real quick. So cube, oops, void, because we're not trying to return anything, cube set depth with an input of depth. And then we are going to have the same if statement. So if the input depth is greater than 0, then we've passed the all clear, and we can set the attribute itself to depth. I just don't want to end it there. I don't want to end that statement with a semicolon, and oops, I clicked that equals more often than I wanted to. And then I'll need to do this because since surface area and volume are dependent on length, width, and depth, I'll need to update surface area and volume when any of the three changes. So calculating surface area is a little bit different. I mean, it's a little bit interesting because usually with surface area, you want to calculate the area of all the sides, right? And if it's, well, like a cube and they're typically all the same, it would just be 6 times the area of one face. But since we have a length, width, and depth that can be changed, what I need to do is I need to go through the permutations of each 2 sides of the cube. Right, so I'll need to do 2 times the length times the width plus 2 times the length times the depth, and then 2 times width times the depth. So I'll reflect that right now. So here I use backslashes to kind of continue what I want to do on the same line, right? So if I put all of this all on the same line, it'll be the same thing as me adding the backslash and continuing what I want to say here. Right, so the calculation of surface area with a cube that can have a variable length, a variable width, and a variable depth is that we need to get essentially the two surface areas that are parallel with each other, right? So there's like the front face and the back face, and like this can be the sides, and this can be like the top and the bottom of the cube, right? So we need to get each one of these. If this was a totally even cube, we can honestly just do 6 times the area, right? But that's not always the case. Anyways, from here, we're going to be moving on to volume. So here, change it from rectangle to cube, and then here we'll have our volume. And this will be easier to implement rather than our surface area, because the volume of a cube is just the length times the width times the depth. We have that there. We're going to change this from rectangle to cube. Oh man, there we go. So then I'm going to do std out with the depth, kind of just try to add this without too much interruption. So this will change to surface area, and this will change to volume. And yeah, here we're going to be printing out all of the attributes for the class. Now let's continue to the plus operator. This will be changing to cube. We'll change this to C, and then all rectangles will be changed to cube. And then once that is done, we need to go about updating these attributes. So let's do that. And well, actually, since we're going to do that, I'm going to do something a little bit unorthodox. I'm going to do the depth first, and I'm going to say depth plus, actually no, let's not do that. We're going to do it the way that I'd like to. C.depth. So we're going to follow the convention of the previous way of doing the attributes. So what I'm going to do now is that I'm going to set length and width directly to the length and width here, and I need to change this R to a C. And then I'm going to call the set depth, so that way I can update the surface area and the volume. Again, this is just like a minor optimization just so I don't multiply as much as I need to. But then we will continue. I need to do the operator for the multiplication. So we'll do operator multiplication of an integer I. So with this I don't trust it, because this can be a negative value, unlike with the const cube C here, where it will pass the setter checks or be equal to 1. This I can be anything. So I'm going to create my cube temp, and because I don't trust the value of the I, I'm going to be doing set length, set width, and set depth for the multiplication of this I. Right, and this, I mean, again, this is just a safeguard, so that way I make sure that, for example, if someone tries to get wise with me and they're like, hey, I'm going to try multiplying this by -1, well, these setters are going to help prevent that. And with that, we have our multiplication. Next comes the equals operator. Oops, I did not want to do that. We'll have cube, replacing more rectangle with cube, and we'll replace R with C, and then here I'm going to put an equal sign, get rid of these parentheses, and then get rid of this. So width, length will be set directly to that, and I'm going to get set depth of, let's get this, I'll call set depth, and then of c.depth. So that way here, right here, I just directly equate the operators, and then here luckily I can call the setter, which again I get to kill 3 birds with 1 stone here because it'll update the depth, the surface area, and the volume. And lastly, we have our std out, the double angle brackets operator for using std out. So I'll need to do the classic of replacing replacing rectangle with cube and replacing R with C. So let's do that. R with C. Well, actually, this will be set to volume, and then we'll have, oh no, well, that wanted to be C dot surface area, and then we'll replace this with C, and then replace this with C. That's all good, and then I'll have out equals C depth with another space, and yeah, that should do it. With that, we've just converted our rectangle class to a cube, and while we did have to change some of that stuff, I mean, this was better than rewriting it from scratch because our rectangle class is similar to cube. Now that we're aware of these parallels, right, when we go about converting our rectangle class to a base class, and then when we write cubed as a derived class, you're going to find out that we have to write a lot less methods just because of it will already be written by the rectangle class. But anyways, let's go about testing cube and just making sure that it works. And here we have it. So I added a few extra lines of code here. So here we have our 2 variables, C1 and C2. C1 we call the unparameterized default constructor, and C2 we call the parameterized default constructor. I immediately call the setter for C1, and I use C1.print. And actually, compared to our last run with rectangle, I changed using cout to using r1.print, because when I make rectangle a base class, the difference, I'm going to do something special with the print method for both of these. So it'll be important to highlight what print does for the rectangle class and what print does for the cube class. But anyways, moving on, after I print C1, I'm going to create C3, which is going to be the sum of C1 and C2, and I print C3. Right, so here I test some setters and my print methods and overloading the double angle brackets, as well as overloading the addition sign. And finally, because with cube, since I wanted to add just a little bit more spice to it, I overloaded the multiplication operator, and we're going to be seeing that there. But before I even try to run any of this, I need to be including cube.hpp, and let's hope that there's no errors. Real quick, I had to move my makefile here, and here we go about compiling it. Oh, there's an error. Dang. Oh, perimeter. I can fix that real quick. Let's search for perimeter by using the / volume. There we go. Okay, let's try make one more time. Feels good. Hopefully no segmentation fault, and great, this all works. So let's kind of take a look at the math here. So here I have shape, so this all works the same as the last program. So here we have 1 and 1 and 9. So first we print the surface area, so 19. So the volume is correct. This looks a little bit suspicious. Let me double check my math. Oh no, the math works because it's going to be 1 times 9 times 2, which is going to be 18, and then this 1 times 9 times 2, which is another 18. So we add 18 with 18. Oh no, this is 36, because this is essentially 4 times 9, which is 36 plus 2 is equal to 38. Yeah, so the math works out for all of this. I was just tripping out. But you guys feel free to double check all this math. I think it's right. And this is our cubed class. So you see that it's very familiar to the rectangle class. So in the next video, what we're going to do is that we're going to make a rectangle class a real base class because right now it's not. It's more of an independent class. The thing that kind of makes it look like a base class is the fact that we're using protected instead of private for the attributes of rectangle, as can be seen here. As can be seen here, right, that this is protected rather than private. But other than that, it's not really prepared to be a base class. So in the next video, we'll make it a base class so that way cubed can inherit from rectangle. And well, you saw how much time I spent working on the methods for cube. Once rectangle inherits from cube, I'll be spending a lot less time writing those methods, and you'll see that in the video after. So I'll see you there.